Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform. I welcome you all to this platform. Just a minute. So I welcome you all to this platform, and before starting this lecture, let me give a brief introduction about myself. My name is Vidyapati Kumar, and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research. I have qualified GATE twice, and I'm the author and co-author of various research papers publication of national and international journal of repute. If you have a keen interest about the research, you can Google about me and read the research works. You can follow me here at the unacademy.com at the rate of v.kesar, where I am currently teaching the strength of metal full course of GATE 2021. For GATE 2021, full course is being taught here. So basically in this session we are going to focus on the numericals of sheet metal operations. We are going to see the concept of shear. We are going to see the concepts of shear. We are going to see the concepts of energy in the planking and punching operations. Before that, if you have not downloaded the Unacademy Learning app, download the Unacademy Learning app as it is totally free. There is a free section in that is totally that you can watch here. That is a special class. So here there would be a special class which is in which I am teaching the strength of metal. So you can always go and attend my special class and definitely attend the SOM lectures which is totally focused on GATE 2021. So the benefits of the Unacademy Learning app is that daily live classes are there, courses are very much structured in nature, tests and quizzes you can give, and the unlimited access of the free course content materials are there. If you have not taken the plus subscription, take the plus subscription. That is totally worth it. Definitely, that is 100% coverage of the syllabus would be there. So in that, daily live classes are there, so you would be interacting with your educator, and courses are well designed in a proper structured manner, so that that is very much beneficial for you. Test and quizzes you can give, and the unlimited access of the all the contents whatever is present in the Unacademy app. That is totally paid as well as free. And the subscription that is known as iconic subscription, basically in this iconic and the plus subscription, one subscription give you the access of both the examinations, that is the GATE and the ESE. And in this subscription basically you will be getting all the benefits of the plus, and after these benefits you will be choosing any of your educator to be your personal coach, and that educator is liable to help you throughout the preparation of GATE and ESE. That educator will also track your study and monitor your performance. That will be that in terms of, suppose if you are giving the mock test or the practice test, suppose that you are giving that and continuously you are scoring the very bad marks, then definitely the personalized test analysis would be very much helpful for you, because in this analysis everything would be getting into detailed discussions would be given to you, why exactly you are committing these kind of mistakes, where exactly you are committing these kind of mistakes, whether the mistakes are conceptual or the silly mistakes you are doing. So everything would be given to you, and these are the benefits that you will be getting in the iconic subscription. These are the benefits that you are getting in plus, and these are the extra benefits that you are getting, such as personalized test analysis would be given, preparatory study materials like PDF and the other course materials would be given to you. Each and everything would be very beneficial for you if you want to take the subscription. So definitely you will be having also the opportunity to learn with the top educators also. For GATE and ESE, there are a lot of batches which has already been started. So there are a lot of batches which has already been started for the mechanical, civil, electrical, electronics, production, industrial, so on and so forth. But definitely you can go and check out these batches as if you want to enroll in that. So these are the batches which has already been started, such as the rank booster batches for the electrical, such as the target ESE prelims batch for the mechanical, which is the batch B, or the batch A are there. So definitely rapid revision batches are also there. GATE preparation in 90 days are there. Revision batches for mechanicals is there. Doubt clearing batches are there. Okay, so there are a lot of batches which has already been started in the month of October and November. So definitely you can go and check out these batches if you want to enroll in that. If you want to enroll in the plus subscription, these are the amounts for the 1 to 3 months. These are the amounts. So those who are in a preparation for GATE 2021, so definitely they can go for the 1 month or a 3 months plan. And those who are in a second and or a third year, definitely they can go to these plans based upon these choices. And whenever they are going for these plans, use my code SIRVK SIRVK to get a 10% off, and you will be automatically enrolling in my personalized mentorship program. Suppose that if you are enrolling for a 12 months plan, that is 30,250, definitely the discounted amount would be 27,225 after using my code SIRVK SIRVK. Also, similarly, if you're going for the iconic subscription, these are the amounts for the iconic subscription. But again, use my code SIRVK SIRVK to get a 10% discount. And definitely, you are also enrolling in my personalized mentorship program after enrolling with my code. Good evening, Swamraj. Good evening. So let's start our discussions of what we have seen. So till now we have seen these things. Till now we have seen these punching operations and the blanking operations. We have seen these things. What are the things that we have seen? Just a quick recap with that, because we are going to deal these things throughout our discussion. So these things should be clear in your mind. So in the punching operations, we have seen the punch size is true or the exact, or in the blanking operations, we have seen die size is true. So basically, this is the first one is the product of the punching, and second is the scrap for the punching. And in the blanking, this is your product and this is your scrap. Fine. Now in this case, in the punching case, we have seen that punch size is always equal to size of the hole, and die size is always equal to size of the blank for the blanking operations. Next, we have seen the punch size we can find by die size minus of twice of clearance, and die size for the punching operations we have seen punch size plus of twice of clearance. Next, we have also seen that how we can find the punch size if we have a die allowance. Suppose there is a no allowance. So no allowance case we have seen like that. Now, if we have been given in the question die allowance, so definitely we are going to subtract the die allowance from the die size to get the exact die size, and definitely from here we can find the punch. These kind of materials. Suppose this is a circular material that you have blank. Now, if you have blank these kind of materials, that is T. Now diameter is d. So for this case, the perimeter would be pi into d into, and the shear area basically find the maximum force which is applied in the blanking operations. Fine. If we have blanks this kind of a shape things. Okay, so if we want to blank these kind of shape features, definitely for this case the shear area is going to be different, and the shear area would be twice a plus b into t. We have also seen the minimum diameter for the punching and the piercing, that is actual is equal to sigma crushing into pi by 4 d square is equal to tau pi into d into t. Basically what we have done, basically we have equated these two, piercing pressure and the strength of sheet. So what is the concept behind it? The concept behind it was that if there is a punch and there is a sheet, so punch will be crushed out. Punch will be crushed out if the F applied, the whatever the force that you are applying is greater than the critical compressive strength, and hence the minimum diameter for punching would be by found by this formula. Fine. Now we have also seen the capacity of the press for the blanking operation, which is also given by P max into C, where P max is nothing but tau L into T. Where what is the L? L is the perimeter. Suppose this is a shape which we want to blank. Now for these kind of shape, the L would be twice A plus B. Now for these kind of shape, L would be pi into T. So let's start our today's discussion of some topics. Hello Amolji. Hello everyone. तो चलिए आज का जो डिस्कशन हम स्टार्ट करते हैं. सो वी हैव नॉट टॉक्ड अबाउट द एनर्जी, राइट, बट वी नो दैट सपोज फॉर द blanking and the punching operations, since the force is associated with it, right, and definitely the energy would also be required to blank or to punch, right, whether it is a punching operation or a blanking will be there, and definitely we are going to analyze and the power for punching and the blanking operation. So let me write it here. Energy and power for punching and blanking. Now see here, we have seen that what is the maximum force that is here. We have seen that maximum force, what you are doing. So your punch would be, see, this is your punch, this is your sheet. What is happening here, your punch is actually traveling inside the die, isn't it? You're traveling. Is my audio video clear to you? Just let me know. Okay, right, this is your punch and this is your die. This is your die. Fine. Now this is your sheet. So basically, when you are applying the force on, when it will be getting inside the sheet, now everything is fine. Just let me know. Okay. So basically, what I was discussing that if this is your die, suppose I'm explaining, re-explaining the things. If this is your die and this is your sheet, fine. This is your sheet and this is your die. Now what you are doing, this is your punch. Now what you are doing, you are applying a force on the punch. So what would be there? Your punch will be getting inside that sheet, isn't it? So punch will get inside the sheet. Now, now there is a question that actually suppose the punch has traveled this much amount. This much amount is the punch travel. Fine. Suppose this is your punch travel. Fine. That this much amount of distance has been traveled by the punch. So here the ideal energy required, that is denoted by E, would be given by maximum force into punch travel. Now, what is the maximum force we have seen? We have seen the maximum force to be P max, isn't it? We have seen in the earlier case P max. Now, see, what is the punch travel? Basically, this is your thickness T. Basically, this is your thickness T. So, punch travel is denoted by P into T. Please try to understand very carefully what is P and T. I will explain these things. So basically we are getting the E is equal to P max into P into T. What is P and what is T? So T is the thickness, and see here the punch is penetrated. See here, if the punch is moving in this direction, the punch penetrated this much part, isn't it? So there is a penetration which is actually inside the sheet. Fine. So what we can write here, the P is percentage of penetration required for the sheet for blanking or punching operation. Okay. Okay. So this is what is we have seen. This is my energy required. Now, so see here, if this is your punch, right? This is your punch. Now, what is the function of the punch? So punch will, this is your workpiece, and this means this is your sheet, and this is your punch. So punch will come down, do the punching operation or the blanking operation. After that, it will come here. So you can see here that it is traveling this distance and then it is traveling this distance. So this is known as one stroke. What is the one stroke? What is the meaning of stroke? Basically, the punch is coming down, doing its operation, and then coming to the back to the its original configuration. So this is known as one stroke. Now suppose that entire sheet is there. Now in the sheet you are performing n number of strokes. Why you are performing n number of strokes? To make the n number of operations. Suppose that you are trying to make n number of blank or the n number of punch. So for that n number of operations you have to do. So let us assume, let us assume, let n be the number of strokes per minute. So if n is the number of strokes per minute, then how you can find the ideal power? See, this is the energy is required, right? This is the energy required, right? So energy required, we have seen this is the energy required, right? This is the energy required, which is E. So this is actually power. Now what we are saying that if you are performing n number of strokes are there, right? अगर एक स्ट्रोक में इतना एनर्जी मिलता है, try to think like that. Try to think like that. If you are getting the energy in one stroke, if you are getting E amount of energy in one stroke, then you are performing the n stroke. So definitely the ideal power would be E into n times. And if you're dividing this by 60, then answer would be in watt. Okay. Now see here. Now see here, if we want, suppose that if we are performing the blanking or the punching operations, so basically that is the machine which is performing the blanking and the punching operation. That is the press we have seen. Now if that is the press, so if we want to find the efficiency of the press or the machines, how we can find efficiency of machine? So basically how we can find the efficiency of machine for punching and blanking operation So the efficiency of machine we can find by, suppose it is noted by efficiency neta, which is equal to ideal power by actual power. Now what is the ideal power? Just now we have seen what is the ideal power. Is it En by 60? Fine. So I can write here, from here, if we want to find the actual power which is required, so we can find that actual power is nothing but ideal power is what? It is En by 60. If we divide this by neta, that is the efficiency, then we will be getting the actual power. So इतना सारा formula याद रहना चाहिए which is related to the energy, and these all formulas are important because from these all formula the questions are asked in GATE and ESE. Okay, this is very much important. Now see here. Let's talk about the concept of shear, that is we give the shear on the punch. So what is the shear and these things, because this is very much important concept for the GATE point of view. So let us start our concept of shear on punch. See here, if I have a punch, suppose this is your sheet. Okay, this is your sheet, and on this sheet you are applying the, this is your punch. Fine, this is your punch and this is your die. This is your die. So what is the diameter of the punch? Suppose the diameter of the punch is D. So D is the diameter of punch. Clear? Now what I have told you, suppose that after some time that the sponge has penetrated this much part, suppose it has penetrated E times T. So this is the punch travel. This is the punch travel what we have discussed. And what is this? This is your T is the thickness. T is the thickness of the sheet. Now for this case, what we have found the P max. What is the P max that we have found? Suppose means like this is the diameter D is there. So what we can understand, the P max would be tau into pi into D into T. So this formula is known to me. Now this is the maximum blanking force that is required here, isn't it? Now see, if we want to find the energy, if we want to find the energy, suppose it is noted by E, how we can find the energy? Just now we have seen in the previous, that is nothing, P max into P into T, isn't it? See here we have seen, this is the formula that we have seen, P max into P into T. Fine. Now see here, for this kind of case, in this no shear is applied. What I mean to say from here, that suppose that this is your sheet. Okay, try to understand very carefully. If you cannot understand, just let me know. Now suppose this is your sheet, and on this sheet what you have done, this is your punch. So basically on the punch you have given some kind of inclination to it, and this is your shear on the punch. So this is your punch. Now why the shear is applied? sheयर हम क्यों अप्लाई करते हैं? अगर आप घर में भी देखें तो चाकू पे आप जो है थोड़ा सा धार देते हैं, and that is like inclined in nature. So basically what is this? It is inclined by the theta. This is known as theta. This is this is this diameter is D, and this is the theta, and this is the shear which is applied. So S is the shear. Fine. So let me write it here. S is the shear applied. Shear applied. Theta is the shear angle. Theta is the shear angle, and this is your tie. This is your die. Now see here, if this is the S and this is the diameter D, so can you say that your theta would be tan inverse of S by D, where S is the shear and D is the diameter, just by geometry. Now what you can see here, if you are talking about the energy in this case, if you are talking about the energy in this case, now I don't know the whatever amount of the force would be applied in this case, because this is not known to me, because the dimension has been changed. Okay, so orientation of the punch and everything is changed. Why it has been changed? Because you have provided the shear. Okay, so basically this is, in this case, shear has been provided. Shear is provided. So for this case, what would be the energy? So energy would be, I don't know the force. Suppose the force which is required in this case for the blanking operation or for the punching operation is, suppose this is Fs. Okay, so let me write it here. Fs is the force required when shear is provided. When shear is provided on punch. Now see here, the energy is Fs into, now in the earlier case, try to understand very carefully. In the earlier case, this is your punch travel, isn't it? This is your punch travel. That is, punch is traveling this by this much amount, by this much amount. Now see here, if in this case, try to analyze that if this is the punch that is going to be inserted here, so this end will be, suppose this end will be inserted like this. Let me draw here. Let me draw here. So suppose this is your heat and this is the punch. So earlier the configuration of this punch was this. Now after some time, punch has reached to this place. After some time, punch will be reaching, suppose this place. So what we can see here, what you can very much assured about it, that suppose that it is reaching to this part. So this part will be what? This will be P into T. And what is this? This is the shear provided. This is the shear provided. So how much would be the punch travel in this case? Punch has to travel the, suppose they want to cut it, so for cutting purpose you have to travel P into T, and this is the S, that is the shearing distance which has been already been applied in this punch, so you have to also travel this S distance. Clear? So for this case the punch travel will be, for this case the punch travel will be P T plus of S. Okay, so I hope you understood. This is the S. So now if this is the case, so what you can write here, the what is the whatever the amount of Fs is there into Pt plus of S. So this is going to be my energy in this case. Now see here, basically the energy which has been supplied or which are supplied in case of a punching operation or a blanking operation, they are being supplied with the flywheel, and the constant energy is being supplied. Okay, so try to understand that whether you are giving a shear on a punch or not, energy supplied would remain to be constant, है ना? क्योंकि energy तो आप flywheel से supply कर रहे हो, तो flywheel constant energy supply करेगा. तो फिर यहाँ change क्या आ रहा है? क्यों हम शेयर दे रहे हैं? तो आपको जस्ट 2 मिनट रुक जाएं, you would be getting understood why you are giving the shear. So now if energy would be same, so can I equate these two equations? Now if I would be equating these two equations, so I would be getting P max into, let us denote this to be PS, let us denote this to be PS, fine, which is PS is the uh, PS is the force required. Okay, PS is the force required, so that our notations would remain constant. Now see here, this is the PS. So what we can write here, P max into P into T is going to be is equal to PS into PT plus of S. Now from this equation you can see that PS is going to be is equal to P max into P into T by PT plus of S. Now from this equation, what is the P max? P max is the maximum blanking force or maximum force, I can write it here. And PS is the required force when shear is provided. Now from this above equation, you can very well say that PS is this and this is the P max. So you can very easily say that the force required for the when shear is applied, this is going to be less than the P max, isn't it? So basically, the if you are talking about the graph, suppose if you want to plot a graph between the force applied, in this case force applied versus the travel of the punch. So this is the in this length punch is traveling. So if you want to plot a graph, suppose if you're plotting a graph, so suppose this is the force and this is the travel of a punch. So for the first case, if this is your first case, so for this case, what is the maximum force? So this is the P max, maximum force is there. So you would be writing here. So this is, suppose this is your P max. Suppose this is your P max. So somewhat here, this is going to be your P max. Now somewhat here this is going to be your P max. Now this is the amount of the punch travel. So what is the punch travel in this case? In this case the punch travel is PT, isn't it? So this whole distance would be PT, isn't it? So this is your entire, this entire graph will give you the energy. Now you can visualize this graph by this equation also. See here what you have written. You have written that energy is equal to P max into P into T. And what is this P into T? What is this P into T? Is it punch travel? Now P max into P into T is the energy that you are getting, and from the graph also you can see here the area under this graph, that is the P max and the travel of punch, would give me the energy, isn't it? This would be your energy. Now in the other case, when you have given the shear, suppose when you have given the shear, so what is the difference that you are actually getting here? So in this case you have to travel the extra s amount, you have to travel, isn't it? This is the s distance you have to travel extra. So what you can understand that here the travel is actually increasing by the s. ओके तो अगर आप शेयर दे रहे हैं ना, तो शेयर के केस में आपको पीटी भी ट्रेवल करना पड़ रहा है और एस भी ट्रेवल करना पड़ रहा है. तो फॉर दिस केस what is happening, you are getting a graph like this. You are getting a graph like this. Now you can understand, if this is your graph, so this is your PS, that is the required force is PS. Now here what you can understand from these two graphs, that energy, for this energy is E and for this energy is E. So energy is same for the both the cases. Why? Because area under the graph is same for both the cases. But where is the difference? Difference is here. So when you have applied the shear, when you have applied a shear on the punch, so your force requirement of force has been decreased. Fine, your requirement of force has been decreased. So these are the benefit that you are getting. Fine. So what we can write, why exactly we need the shear on the punch? So what are the benefits? So you can write here that shear on punch, when you have given the shear on the punch, you have observed that to reduce the shearing force, shear is grounded on face of punch. So this is what we have seen, that on the face of the punch shear has been grounded. And see here, when you have grounded the on the face of the punch, you have given the shear, and when you have given the shear, you have found there is a reduction in the shear force, right? There is a reduction in the requirement of the force. So you can see here, this is the first point that we have seen. Now we have also seen that my force is actually distributed. Okay, my force is actually distributed, so it distribute the cutting action over a period of time. Next, what we have seen, that shear only reduces the maximum force to be applied, but total work done remains same. टोटल वर्क डन और द एनर्जी रिमेन सेम, इजंट इट? हमने ये भी देखा है कि एनर्जी तो सेम हो रहा है ना, दोनों के केस में एनर्जी इज गोइंग टू बी सेम. So basically these things are very much important from your gate point of view, and I hope you understood these things. Any doubt in these entire whatever I have explained you? Any doubt in this entire thing? Just let me know if you have any kind of doubt. This is the energy that you have found for This is the energy that you have found for the case of the first case when the shear is not applied, and on this case when you have applied the shear, this is the energy that you have found. And based upon that, this is the very important formula that you have got. PS is equal to P max into P into T by PT plus X. Ravi Kanji, basically I am using the pen tab to write it. Any doubt in today's session? Whatever I have explained to you? Okay. So I hope you understood these things. So let us try to solve some of the questions related to the topics what we have seen. Okay. So this is what is the shear that has been given. Fine. This is the shear which has been given on the punch. Here this is the punch, and this is the shear which has been given. Fine. So I hope you understood each and everything. See here, this is the GATE question which has been asked in a GATE 2020. So in this question, it has been told a sheet metal with a stock hardness of 250 HRC to be sheared using a punch and a die having a clearance of 1 mm between them. So in this question, they have been said that a sheet metal which is having a 250 HRC. Clear. So this is the hardness which has been given. Now, in this, they have told that clearance is 1 mm for them. Okay. Now, if the stock hardness, so they are saying that if the sheet which is having in the earlier case, the sheet is having the 250 HRC and clearance is 1 mm. Now, in the other case, they are saying that if the stock hardness has increased from 250 to 400 HRC, then what would be the clearance? What would be the clearance between the punch and the die? Now, first thing that you should always keep in mind that I have told you the first formula. If you could remember in the very first beginning session, I have told you C is equal to 0.003 T into root over of tau. Root over of tau. Root over of tau. Where tau is the shear strength. I have explained these things, but again I am re-explaining these things. Tau is the shear strength and T is the thickness. Now basically this shear strength is actually proportional to the hardness number. Okay, hardness number. So what you can say here that if shear strength is proportional to hardness number, then what we can say here that C would be proportional to the hardness number. And which is C? It is under the root. So definitely this is going to be root over hardness number, isn't it? Now see here. Now see HRC is actually, see here, HRC is actually a Rockwell number. This is actually Rockwell number. R for representing the Rockwell number. Clear? Brenell hardness number is there. Rockwell number is there. So R represents the Rockwell number. Fine. अलग अलग आपका मतलब हार्डनेस का यूनिट्स होता है जब आप अलग अलग डिवाइसेस यूज करते हैं. ठीक है. So basically this is the C is proportional to the hardness number, and from here what you can understand the clearance is there. Now in the first case C1 by C2 I am doing here is equal to root over, let me write it the hardness number as H1. So what you can say here, root over of H1 by root over of H2. Now what is the C1? So in earlier case it was given as when 1 mm is there, so 1 mm is the C1. C2 you don't know. What is the hardness in the first case? It is given as 250. So you can write here that it is given as 250. And what is the H2? That is the 400. This is going to be a root over. So from here C2 can be found out by root over of 400 by 250 into 1. And from here you can say that C2, that is the clearance in the second case, would be nothing is equal to 1.265 mm. Okay, so in this case the clearance would be 1.265 mm. Fine. Any doubt in this question? Any doubt in this question? If you have no doubt, then definitely try to solve this question. Try to solve this question and tell me the answer. Try to solve this question and tell me the answer. I'm waiting for your reply. Try to solve this question and tell me the answer. Try to find the solution of this question and tell me the answer. You can solve this question or not, just let me know. Otherwise, I'm going to solve this question. Okay. So see here. Okay, see here in this question, it has been told that a disc of 200 diameter. So basically, there is a disc of 200 diameter is blanked from a strip of aluminum alloy of thickness 3.2 ठीक है. तो क्या यहाँ पे बोला गया है कि that there is a sheet. Fine, try to understand, there is a sheet, and from the sheet a 200 diameter is blanked from the sheet. So basically there is a punch, and with this punch, this is the die. Here, this is the die, and this is the diameter. So diameter is given as 200 of the punch, and from here this part is blanked out. Means this part is blanked out like this. ठीक है, ये आपका ब्लैंक करके निकल जाएगा. अभी अगर ये ब्लैंक करके निकल रहा है, दिस इज योर टी एंड दिस इज योर डी. So if that is the case, what is the perimeter? Or see here in this question, we are basically interested in the blanking force. So the blanking force is given by tau, that is a shear strength, into L into the T. What is the L? L is the perimeter, we have seen that. And what is the L? In this case, it is pi into D. Right. Now, if L is the pi into D, you can write here tau. So what is the tau? Is it 150? Write it here. That is going to be 150. And in this case 150 Newton per millimeter square would be there, into L, which is going to be pi, into diameter is what, 200 Now what is the thickness? Thickness is 3.2. Just substitute these things, and from here and square get cancelled out, and you will be getting the blanking force, that is the P max, would be coming to be around 301.592 kilonewton. I was expecting the answers from you, but I don't know why you have not given the answer. 301.592 is the answer. So option B would be the correct answer. Okay, so I have got answer from Khyati, Asis, Ravikant. Very good, very good, very good, very good. I was expecting the answers because these questions has already been solved in this sessions. Please try to solve this question. Please try to solve this question. And meanwhile, if you have any doubt in the today's session, because in the today's session I have discussed about the energy required for the blanking and the punching operations. I have also discussed about the concept of the shear. Basically, when we are giving the shear on the punch, what is going to be the scenario and the force requirement, energy requirement, these everything I have told in entire thing. So if you have any kind of doubt in the entire thing, definitely just let me know, because we are going to solve a lot of problem in that. Okay, Kati C, Ase C. Okay, yes, this is very basic question. Again, this is a very basic question. So So see here, a circular blank of 10 mm diameter are punched from an aluminum sheet of 2 mm thickness. The shear strength is given as 80 MPa. So basically the shear strength tau is given as 80 MPa. Okay, so Subham Raj is also giving the answer. Okay, 80 MPa is the shear strength and aluminum sheet is having the thickness of 2 mm. Fine. Now you are actually blanking a 10 mm diameter. Fine. So diameter of the blank is actually 10 mm. And my dear friend, you need to find the punching force, right? So you can very easily apply the same formula. That is the P would be tau pi d t. Fine. और यहाँ पर आप कर दें यहाँ पे 80 न्यूटन पर मिलीमीटर स्क्वायर. Pi diameter would be 10 mm, thickness would be 2 mm, and you are done. 5.026 kilonewton. Okay, so this is going to be your correct answer. C. Okay, very good, very good. Khyati, Ases, Subham Raj, Bhagyasri, very good. Okay, so since Ases you are late, so okay, I would give you a brief recap after some time. Don't worry about it. Now see here. See here, this is a question which has been asked in GATE 2014. Try to solve this question. Try to solve this question and tell me the answer. Try to solve this question. Try to solve this question. This is again, this question is very much simple, but yes, something would be different from the conventional what you have seen or whatever you have been solving. But again, the same concept is there. Same concept is. Basically, in this case, the shear area is going to be different. Okay, this is the hint that I have given to you. Now, please try to find the answer. Okay. Khyati is giving option B. Okay. What about others? What about others? Swamraj B. Okay. So basically, in this, what is the in this question? It has been told that there is a rectangular hole of size 100 mm into 50 mm is to be made on a 5 mm thick sheet. Okay. So the sheet is having the thickness. So T is actually 5 mm. Okay, and the size is 100 into 50. So assume that this is A and this is B. So basically the A cross B is given as 100 cross 50. Okay, this is given to you. So is to be blanked. Now in this question the given is shear strength is 500 MPa. So basically if the shear strength is given as 500 MPa, Bhagyasri is also telling option B. Okay, try to solve it, try to solve it. Now see here, 500 MPa अगर आपका shear strength given है तो आपका shear area क्या होगा? Tell me the shear area. Shear area will be twice of A plus B into T, isn't it? Now in this case, twice of 100 plus of 50 into T is what? T is 5 mm. So I can find that punching force. So punching force would be nothing but tau into this is the shear area twice into A plus P into T. Plug in the figures. When you are plugging the figures, that is the 500 Newton per millimeter square twice of 100 plus 50 into 5. You will be getting the answer as P would be coming to be around. This is Option B that you are getting. Very good. So this is 450 kilo. Option B is the correct answer. Now try to solve this question. Now try to solve this question. This is a very good question. This is a very good question. Try to solve this question. Try to solve this question. For punching a 10 mm circular hole and cutting a rectangular blank of 50 cross 200 mm from a sheet of 1 mm thickness, in whose shear stress is given as 240 Newton per millimeter square, you have to calculate size of punch, size of die, and force required. Now, please hold on, hold on, hold on. Let me explain you this question, and then that will be better for you to solve. Now, see here in this question, it has been told that for punching a 10 mm circular hole. So basically, there is a problem of punching. So in this punching, basically you have to make a 10 mm circular hole. Clear? Now again they are saying that cutting a rectangular blank. So basically there is again a problem of blanking. And in this blanking problem, they are telling you that they are taking a blank of 50 cross 200 mm. Okay? So they are making a blank of this much of dimension. And what is the sheet? So in this case also sheet is 1 mm. In this case also sheet is 1 mm. So for these cases you need to find for this punching, find the size of punch, size of dice, force required. For this blanking, again find the all of the three. Okay, so for the punching tell me the answer, and for the blanking tell me the answer. Clear? So I hope question is clear to you. कि पंचिंग ऑपरेशन में ये तीनों की वैल्यू क्या होगी और ब्लैंकिंग ऑपरेशन में ये तीनों की वैल्यू क्या होगी, वो मुझे बताना है. तो सबसे पहले जो आप मुझे बताइएगा, द फर्स्ट थिंग दैट यू हैव टू टेल इज फॉर द पंचिंग ऑपरेशन. टेल मी अबाउट द पंचिंग ऑपरेशन. फॉर द पंचिंग ऑपरेशन व्हाट वुड बी द साइज ऑफ पंच, साइज ऑफ टाई, फोर्स रिक्वायर्ड. ओके, टेल मी फर्स्ट ऑफ ऑल, टेल मी फॉर द पंचिंग ऑपरेशन. देन प्लीज ट्राई टू सॉल्व अबाउट द ब्लैंकिंग. फर्स्टली टेल अबाउट द पंचिंग ऑपरेशन. फर्स्टली टेल अबाउट द पंचिंग ऑपरेशन. पहले आप पंचिंग के बारे में बताएं. सबसे पहले बताएं कि पंच साइज क्या होगा. पंचिंग ऑपरेशन में पंच साइज क्या होगा. टेल मी, टेल मी. Tell me, for a punching operation, what would be your punch size? Please tell me. For the punching operation, punch size. My dear friends, it is very much easy question that I am asking from you. For a punching operation, we know that punch size will be is equal to size of hole, and hence the punch size will be what? 10 mm. So this is a very simple question I was asking, and hence I was telling you from the repeatedly from the three classes, I have been keep revising you these this slide, I have been keep revising you this slide, my dear friend. Please try to understand this slide. My dear friend, almost all 99% क्वेश्चन, आप कह लें कि 92 से 93% क्वेश्चंस आपका पंचिंग और ब्लैंकिंग शीट मेटल में यही दो से पूछा जाएगा. और शीट मेटल में जो क्वेश्चन पूछा जाएगा ना, 90 से 92% प्रश्न आप सिर्फ और सिर्फ इसी स्लाइड के बदौलत बना सकते हैं. then why you are not memorizing this slide even if I have explained each and everything, है ना. वो ऐसे मेमोराइज नहीं करना, but try to understand that for a punching operation punch size will be true or exact. So if punch size will be true or exact, definitely punch size will be is equal to size of hole, and that is what is being told in the question. Now for the blanking operation, die size will be true. Now if die size will be true, so die size will be what? Size of the blank. ये जो blank आप जो निकाल रहे हैं ना, वो blank का ही diameter आपका die का diameter होगा. अभी एक चीज सोचें कि if punch size will be true, so definitely you are giving the clearance on the die. And if the die size is true, so you are giving the clearance on the punch, isn't it? Clearance आप दे रहे हैं punch पर, clearance आप दे रहे हैं die पर. So this is the thing that is very much important. If you are keeping this thing in your mind, you will be able to solve the problems. ठीक है, चलिए ख्याति जी ने बताया मुझे आंसर, वेरी गुड. So punch size will be 10. Now what will be the size of die? Please tell me size of the die. What will be the size of the die? Please find the size of the die for the punching operation. Can you find the size of the die? You have to go to the back formula, whatever I have explained you. Size of the die can be found out by punch size plus of twice of clearance. Okay, so Khyati is telling us 10.99. Very good, very good. But please check your answer, Khyati. There is a slight mistake that you have done. There is a little bit slight mistake that you have done. Please check your answer. And from the clearance, you can find the clearance as 0.0032 into T into tau. Nicole is telling us 9. No, Nicole, no. See here, we find the size of the die by this formula. 0.0032 into T root over tau. This is the formula for finding the clearance. Clear? And in this formula, tau is given in the question. See, tau is given in the question. Thickness is given in the question. See, the thickness is 1 mm. So you will be putting here 0.0032 into 1 into root over of tau. That is the 240. That is the 240. Nicole is telling us 10.10. Okay. That is close. That is close. Yes, Khyati. Now it is your answer is correct. So tau is what? Tau is 240. Tau is 240. Now from here you will be getting the value of clearance, isn't it? यहाँ से आपको क्या clearance का value मिलेगा क्या? अभी the clearance value that you have got, put it here. Then you will be getting the size of the die. So very good. I am getting a lot of answers from Khyati, Nicole, Bhagyasri, Suvam Raj. Very good, very good. Each of you have given the correct answer. So what I can find from here, that size of the die is equal to punch size. So basically the punch size is 10 mm plus of twice of clearance. So what is the clearance? Clearance is nothing but it is 0.0032 into thickness. Thickness is what? You have seen that thickness is 1 root over 240. Fine. 1 into root over 240. And this is going to give me as 10.099 mm. Fine. This is the size of the die. Now after that, please tell me the force required. Please tell me the force required in the punching operation. In the punching operation, what would be the force required? In the punching operation, this is the punch size. This is the punch size. This is the size of the die. For the punching operation we are doing. This is the size of the die that we have found out. Please tell me the force required. That is Khyati is telling us 7.53. Okay. What about others? Khyati, you are totally correct. See, again the same question, my dear friend. Again वो same पुराना concept है. पुराना concept आप apply कर दे और आपसे बन जाएगा, है ना? Perimeter निकाले, perimeter will be pi into d and shear area will be pi into d into t, isn't it? Yes. Suvam Raj is also telling 7.53. Very good. So if I want to find the third part is blanking force. blanking force. So if I want to find the blanking force, that is the P max, I would be writing as tau into pi into d into t. What is the tau? Tau is 240 Newton per millimeter square. Put it here, 240 Newton per millimeter square. That is the pi, and the diameter of the blanking is given as 10. Okay, this is the 10. Fine, 10 is there, and thickness is 1. This is going to be square. This mm square get cancelled out. Nicole is also telling Bhagyasri 7.53. Each one of you have given the correct answer. Each one of you have given the correct answer, and the P max would be coming to be around 7.54 kilonewton. So this in this question, whatever the things that has been told to find for the punching operation, that has been done. Now they are asking about the blanking. So if this is a blanking operation, now if this is a blanking operation, now if this is a blanking operation, so basically in this blanking operation, they are finding 50 cross 20 mm. 50 cross 20 mm का होगा, ठीक है, 50 cross 20 mm का होगा, है ना, 50 cross 20 mm का होगा. Okay, 200 mm का होगा. Fine, the mistake, 200 mm. Now please tell me the each one of the things. So let me give you this slide. Now please tell me, for the blanking operation, size of the punch will be what, size of the die will be what, and the force required. Very fast, very fast, just tell me the answers. I'm going to solve a lot of problems, and definitely I'm going to introduce, I have introduced the concept of shear also, है ना. shear punch पे जब shear देंगे तो क्या होगा, energy required क्या होगा. So I'm also going to solve some of the couple of problems based upon the energy and the shear, है ना. कुछ न्यू न्यू कॉन्सेप्ट्स हमने पढ़ा है. हेलो जयंतु जी, हेलो. Please tell me the answer, my dear friends. Please tell me the answer. Please tell the answer. For the blanking operation, what would be the size of the punch, size of the die? Okay, so I'm just solving this. Okay, I'm just solving this. Try to understand here that for the, if we want to find the punch size, then definitely punch size can be found out by die size minus of twice of clearance, isn't it? Now here one thing that has to be kept in the mind, that 9.89 of punch. Okay, okay, are you sure that 9.89 will be there? See here, Nicole, see here, each one of you, see here, you have solved till now, you have solved only the force required for these kind of cases, isn't it? जब भी आपका 50 क्रॉस 200 mm जब होता है, see here, firstly see here, try to see here, and then you will be understanding that when you are doing a blanking operation, so basically you will be getting these kind of shape of the sheet. ठीक है, कुछ इस तरह का चीज आपको मिलेगा, where this is going to be your clearance, this is going to be your clearance, this is going to be your clearance, this is going to be your clearance. ठीक है, तो अगर इस केस में आप अगर पंच साइज निकालने जाएंगे, इफ यू वांट टू फाइंड द पंच साइज, देन पंच साइज विल बी व्हाट, size means what, size means whatever the size that you want to find minus of twice of clearance. Try to understand here, the problem is what, the problem is that the you want to blank 50 cross 200 mm, right? So your punch would be something like that. Your punch will be also be something like that. ठीक है, आपका जो पंच होगा ना, this is going to be your punch. ठीक है, this is going to be your cross sectional area of the punch. Okay, and this is, suppose this is the punch, this is the punch, and from this punch you are giving a force on the sheet. तो एक चीज आप सोचे कि क्रॉस सेक्शनल एरिया कुछ इस तरह का होगा, है ना। यहां पर देखिए पहले केस में आपका पंच कैसा था, पंच कुछ इस तरह का था, पंच कुछ इस तरह का था। तो यहां पर क्रॉस सेक्शनल एरिया क्या था, सिंपल, आप डायमीटर के बेसिस पे आप सारा काम करते थे। लेकिन यहां पर समथिंग ए एंड बी है, मींस लेंथ एंड द ब्रेड्थ आर देयर, so definitely for that punch size will be different for the length and for the breadth. Clear? So just see here and then you will be understanding. So suppose that if you want to find the length size of the punch, so that will be size. So basically the size that you have seen, that is the length, that is the 200 minus of twice of clearance. So basically twice of clearance means what? See here, this is your clearance, this is the clearance, fine. So I can write here, very clearly, that is twice into 0.0032 into 1 into root over of 240. Now if this is the case, then you are getting the length size as 199.90 mm. This is going to be your length size of punch, try to understand, पंच का लेंथ साइज क्या होगा, ये होगा। अभी अगर आप फाइंड करें विड्थ साइज, अगर फाइंड करें आप विड्थ साइज क्या होगा, अभी देखिए विड्थ साइज क्या था, 50 था उस पे, तो 50 था। अभी माइनस क्या करना है आपको, ट्वाइस इनटू, बिकॉज सी दिस इज गोइंग टू बी योर डाई साइज, है ना। आपको याद अगर हो तो दिस इज गोइंग टू बी योर डाई साइज, है ना, ये डाई साइज के बराबर होता था। तो हेंस वी आर आई एम टेकिंग दीज थिंग्स, ट्वाइस इनटू 0.0032 into 1 into root over of twice 240। तो यहां से आपका विड्थ साइज आ जाएगा, विड्थ साइज of the punch would be, this would be is equal to your 49.90 mm। समझ में आया या नहीं आया ये मुझे बता दें, प्लीज टेल मी दैट यू हैव अंडरस्टूड और नॉट। For the punch size, because see punch size is actually, see it is different. Suppose if you are taking this as a length, if you are taking this as a length, so the length is different and the breadth is different. So how can you find the die size, है ना, मतलब आपका डाई साइज जो होगा ना वो लेंथ के लिए अलग होगा और विड्थ के लिए अलग होगा। तो ये समझ में आया नहीं आया, this thing is clear to you or not, just tell me। So what you can understand, that the first case that has been told, size of the punch, so punch size will be this, that is 49.90 cross 199.90, this is going to be your punch size। ये चीज समझ में आया या नहीं आया, जल्दी से मुझे बता दें आप, प्लीज लेट मी नो दैट दिस थिंग इज क्लियर टू यू और नॉट। जस्ट अ मिनट, दिस थिंग इज क्लियर टू यू और नॉट। Now okay, so I assume that these things are clear to you. Now try to find the size of the die. Now please try to find the size of the die. So die size will be the correct size, है ना। तो आई डोंट थिंक दैट यू विल बी हैविंग एनी प्रॉब्लम, बिकॉज आप पंच साइज निकाल लिए तो डाई साइज तो आप आराम से निकाल ही सकते हैं। डाई साइज विल बी व्हाट, डाई साइज विल बी द ट्रू, डाई साइज इज एक्चुअली व्हाट, दिस इज द ट्रू इन नेचर, दैट इज एग्जैक्ट। So if that is the exact thing, so length will be what, 200 mm and width will be what, 50 mm, है ना। और यही तो हमने अभी तक लिया है ना, देखिए 200 और 50, यही तो टाई साइज आपका ले रहे हैं हम यहाँ पे। तो डेफिनेटली दीज थिंग्स वुड बी 250 mm। Now next thing is what? Next thing is the force required. So force required for the blanking. How you can find the force required for the blanking? So next thing, third thing that you have to find is the blanking force. Blanking force. So now blanking force. Please tell me. Please find the blanking force. Now please find the blanking force. I hope each and everything is clear to you. If there is any doubt in understanding any at any point, definitely you can tell me, and I would try my level best to explain you each and everything once again. Please try to find the blanking force. So let me give you again that slide. Okay. Please try to find the blanking force. Please try to find the blanking force. Now this thing is very much easy for you, है ना. ब्लैंकिंग फोर्स तो आप फाइंड कर ही सकते हैं. 120 kilonewton. Khyati is telling us 120. Okay, Khyati ji, very good, very good. What about others? See here, my dear friend, that is very much easy for you. I'm waiting for like 5 to 6 to 10 seconds, and then I would be solving this question, because this is, I expect, minimum expectation is from you that you would be able to give me the answer of this question. चलिए, कोई बात नहीं. Now see here, the blanking force would be what? P max is, we have seen that it is twice A plus B into T into tau. Where, what is this? This is your shear area, isn't it? So you can find P max is equal to twice. What is A? Is it 200? What is B? It is 50. What is the thickness? If you could remember, the thickness is given in the question is 1 mm. And what is the shear stress? Shear stress is given as 240. 240. Okay. And the sheet mm, 1 mm is the sheet thickness. Fine. चलिए ये सब चीज आपको याद होगा. This is going to be your 240 Newton per millimeter square. So P max will be coming to be around 120 kilonewton. ठीक है. चलिए. So I hope these things are clear to you. Please try to solve this question. 2016 PI question is there. Please try to solve this question. Please try to solve this question. Please try to solve this question. The ratio of press force required to punch a square hole and another square hole is given. Okay, so two cases are given. You need to find the ratio. How you can find the ratio? Very easy thing is there. Just first of all, try to find the press force. Okay, try to find the press force, and for the first case and for the second case, and then divide them. Okay, take the ratio of both of the forces and then tell me the answer. Tell me the answer. Point 0.25. Very good, Khyati. Very good, very good, very good. What about others? See here, my dear friends, each and everyone, there is a very easy question is the ratio of press force you need to find. Ratio of press force required to punch a square hole of 30 mm side in a 1 mm thick plate. ठीक है. तो देखिए, पहले पहले केस में आपने 30 mm किया. तो देखिए, पहले केस में अगर आपने 30 mm किया है तो आपको पता होगा कि कुछ इस तरह का आपने, सपोज करें कि आपने कुछ इस तरह का ब्लैंकिंग किया है. ठीक है. Now रिक्वायर्ड टू पंच, ओके, सो पंच आउट करके सपोज करें कि आपने इस तरह का कुछ स्ट्रक्चर को निकाला, तो ये आपका 30 हुआ, ये भी 30 हुआ, तो कैन यू से दैट योर shear area will be what? In this case shear area will be 4 cross of 30 into 1, where 1 is the thickness, है ना, 1 is the thickness. नाउ दूसरे केस में देखिए, दूसरे केस में आपका 60 mm साइड है, तो दूसरे केस में अगर आपका 60 mm साइड है, तो सी हियर, इफ दिस इज 60, दिस इज 60, एंड इन दिस केस थिकनेस इज 2 mm, in this case thickness is 1 mm, in this case thickness is 2 mm. So if you can find the shear area for this case, shear area will be what? 4 into 60, ठीक है, 4 into 60, and into 1 would be a your into 2, right here 2 is there, so into 2 is the shear area. What is this? If you have any doubt, what is this? This is the perimeter, this is the perimeter, this is the perimeter. Now you can find very easily, suppose the p max for the first case divided by the p max for the second case, shear stress cross 4 cross, so suppose that you need to find here that 30 is there, 4 cross 30 into 1 by shear stress 4 cross 60 into 2. So from here you can see the answer that you will be getting here is 0.25. Okay, 0.25 is the correct answer. So Nikul and Khyati, very good, you have given the correct answer. So I don't know, for those who are online, just let me know that is there any problem in understanding the concept, because I have tried my level best to explain each and every concepts, then again it's like you're not giving the answers to me. Is there any problem in understanding the concepts? क्या कहीं पे कोई प्रॉब्लम है जो आपसे बन नहीं पा रहा? Why it is happening? Please openly tell me the problems that you are facing, because after attending these lectures, इतना सारा लेक्चर अटेंड करने के बाद भी अगर आपसे नहीं बन रहा है, then that is a problem. Definitely that is a problem. Is there any doubt in understanding the problem? Just let me know. Please open and tell me if you have any kind of doubt. Okay, no problem. Do not want to tell. Fine. Please try to solve this question. 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 A hole is to be punched in a 15 mm thick plate having the ultimate shear strength is given as 3 Newton millimeter square. Okay, so it is per millimeter square. Fine. It is per millimeter square. Okay. Please tell me the answer. In this question, they are asking about diameter of the smallest hole. ठीक है, चलिए आंसर बताइए मुझे. Please try to solve this problem. A hole is to be punched in a 15 mm thick plate having the ultimate shear strength as 3 Newton per millimeter square. If the allowable crushing stress is 6 Newton per millimeter square, diameter of the smallest hole which can be punched is equal to. Kathy is giving option B. That is okay. Option B is correct. Correct, Kathy. Correct. Very good. Very good. See here, you need to find. See, I have explained this doubt, explained this concept. That's why I'm just I always try my level best to keep revising everything. Have I told this concept, my dear friend? I have told this concept. I have told this concept. This concept is very much important. So just you have to apply these concept and find the answers. Okay. Okay. So try to see here that for that you need to equate. You need to equate the pressing into pi by 4 into d square. So crushing strength into pi over d square, that is the area. Nicole is also giving option that is 30. Correct, Nicole, correct. This is equal to shear strength into pi into t into, yeah. From here you can find it. Okay, so now you can understand that this is a pi, this is d, this is d square, this is going to be d. So if you want to find the d, that will be coming to be tau by sigma into 4 into t, isn't it? So what is the tau? So tau is given in the question is it is ultimate shear strength 3, right? So 3 is given, 3 by 6 into 4 into 15 is given as thickness. You can find the diameter would be coming to be around 30 fine. So 30 would be the correct answer. Chaliye, very good, very good. Please try to solve this question. Please try to solve this question. ESE 2014 problem is there. Try to solve this problem. Try to solve this problem. Please try to solve this problem and tell me the answer. Please try to solve this problem. ESE 2014, a hole of diameter 35 is to be punched. Khyati is giving option C. Okay, very good, Khyati, very good. What about others? See here, a hole of diameter 35 is to be punched in a sheet metal of thickness T. Ultimate shear strength is 400 ampere. Using punching force of 44 kilonewton, you need to find the maximum value of T. ठीक है, T की वैल्यू आपको निकालनी है. सेम काम आपको करना है. क्या सेम काम करना है? शेयरिंग स्ट्रेंथ. शेयरिंग, so shearing force would be is equal to, so see here, if you want to find it, so you know that shearing force should always be less than the crushing force, है ना? This thing is important because you know that is to be punched, and the maximum value of T if you need to find, so you know that shearing force would be less than is equal to crushing force. And what is the shearing force? That is nothing but tau pi into d into t, which is less than equal to sigma c into pi by 4 into t square. Now from here you can say that t would be greater than equal to 4t tau by sigma c. And from here just put the values, and you will be getting the minimum value of diameter, that is coming to be 10 mm. Okay, so here the punching force is given. Okay, here the 400 MPa is given to you, each and everything is given to you. From here you can find the value. Just a minute. Just a minute. Basically, what is the P max? P max is nothing but shear area into tau. And in this question, the 44 kilonewton is given, 10 to the power of 3. Okay, the shear area would be pi into d into t into tau. Tau is given in the question is 400 MPa. Okay, and what is the diameter? Diameter is given as 35 mm. Put it here. So from here you can find the value of t, that is 44 into 10 to the power of 3 by 400 into pi into 35. Okay, so from here you will be getting the value of t kindly. So you can find the value of t, that is coming to be around that will be 1.0004 mm. So answer would be option C. Okay, please solve this question. 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 With a punch for which maximum crushing stress is 4 times the maximum shearing stress of the plate, biggest hole that can be punched in a plate would be of diameter equal to. Okay, so here in this case you can apply that concept, that is the crushing force would be greater than the shear force. ठीक है, यहाँ पर वो कॉन्सेप्ट लगा दीजिए और आपका बन जाएगा आंसर. प्लीज टेल मी द आंसर. प्लीज टेल मी द आंसर. प्लीज टेल मी द आंसर. Please tell me the answer. You can find it very easily. C. Okay. Very good. What about others? Nicole is telling option C. Very good, Nicole. What about others? What about others? What about others? See here, the crushing force will be what? Crushing force will be nothing. Sigma crushing into pi by 4 into d square. Just you would be just what I have done earlier. So that is the tau into pi into d into t. So from here you can find that your t would be coming to be 4t tau by 4 tau. Clear? So t will be, again, this is the equal to plate thickness, isn't it? It is equal to plate thickness. Okay, okay. This is the diameter that is going to be is equal to plate thickness. Please try to find this question. So this is also the same question. Okay, this is also the same question. So take this as a practice question. Take this as a practice question and try to solve this in the home. Now please try to solve this question. Please try to solve this question. I have explained the concept of penetrations and each and everything. So I hope each and everything is clear to you. Concept of penetration and other things. So if that is clear to you, please try to solve this problem. Or should I repeat the concept of penetrations and energies? Just let me know. Just let me know that should I repeat the concept of penetration, shear and energies, or you would be able to solve this question. Just let me know. Okay. See here what I have explained to you, my dear friend. So you are telling that I should repeat, right? So just a minute. I'm just repeating the concepts. So basically, try to understand these things I have explained you. These things I have explained, that energy and the power for the punching and the blanking. Okay. For a time being, I'm just going a very fastly. I'm going. You may later on you may watch the videos again so that to get a proper understanding. Now here what I have told you, total energy that is going to be required for the punching and the blanking is going to be maximum force into punch travel. So basically what is the punch travel? See, this is the dimension of the punch. Now punch is actually traveling somewhat here. Suppose this is the punch, so punch will travel up to here. So it will be traveling inside the thickness of the plate. So suppose this is a sheet, so it is actually getting inside the sheet. So suppose it is getting inside the sheet, and so this is the travel, this much amount is the travel that punch has traveled to penetrate, right? So basically this is the punch travel. So what is the punch travel? Punch travel is given by P into T. So maximum force, that is the P max. Just now we have seen P max for the if you want to make a circular cross section things, then definitely P max is what? Tau into pi into d into t. So that is the P max. P max into P into T, where P is what? Percentage of penetration required for the sheet for blanking or the punching operation. So here suppose you your punch has moved 40%, 40% of the thickness है ना, 40% नीचे चला गया या 50% नीचे चला गया, that is the penetration. So basically the penetration that would be given in the percentage. So P into T is this. So that is the energy that is going to be there. Now if n is the number of strokes per minute, suppose that this is the punch, fine, and this is the die, and this is the sheet, fine. So suppose that punch is moving down and it is doing a punching or a blanking operation, fine. After that again punch is moving down, again doing the operations. So what is here, what is the thing that you should always remember, that punch is actually coming down and doing the operation and then getting back to its original configuration. So this is known as one stroke. Again it is moving down and again it is moving back to its original configuration, that is known as another stroke. So basically if assume that n number of stroke is there, so this is the energy that is produced for a single stroke. Now if that is the energy, that is the energy that is being produced for the n number of stroke, so definitely you have to multiply this E by the n multiplied by n, and if you divide by the 60, you will be getting answer in the watt, isn't it? Now try to understand what is the efficiency of the machine for the punching and the blanking. Suppose there is a press है ना, press में ही तो हमारा punching और blanking होता है. So if you want to find the efficiency of the machine, then how you can find the efficiency of the machine? That is equal to ideal power by the actual power. Now if what is the ideal power you have just calculated, this is the ideal power, that is En by 60, isn't it? Now what you will do it, you will find the actual power, that is going to be En by 60 into efficiency, where this is the efficiency of the machines, fine. So this is how you can find the actual power. Now I have also told you about the concept of the shear on the punch. So what is the concept of shear on the punch? So basically this is the diameter of the punch, and this is the thickness, this is the sheet, this is the sheet on which you are punching. So basically if you could understand, this is this much amount of punch travel is there. Okay, so this much amount is the punch is traveling inside it. So if this is the amount by which the punch is traveling inside, so this is the punch travel, that is the P into T. So if you want to find the P max, you know the P max would be tau into pi into d into t. Now if you want to find the energy, so energy is what? P max into P into T. Just now you have seen P max into P into T, isn't it? So this is the P max into P into T. Now P into T is what? P into T is punch travel. P into T is the punch travel. Now see here, if you want to find the energy, you have multiplied by the force, maximum force, into the punch travel, isn't it? Now if you would plot a graph, try to understand that if you would plot a graph between the force and the travel of the punch, between the force and the travel of the punch, so you have seen that this is the P max, that is getting in this equation. So that is the P max, and this is the P into T is the punch travel. Try to understand, this is the P into T is the punch travel, and P max is the maximum force. So this is the product of this. So I have plotted down a P max here, and this is the punch travel P into T. So this much amount is the rectangular portion that you are getting in the graph. So this is what, this is giving me the energy. Now if you would give a shear, suppose you are providing a shear on this punch. Why exactly you are providing the shear on the punch? So basically my requirement is that to reduce the force. Suppose you are giving the 10 newton or 10 kilonewton of force you are giving for the punching operation. Now I do not have the 10 kilonewton of force, I can only give the 5 kilonewton. So can I do the shear? Yes, I can do the shear. So for that you need to provide the shear. So for that, if you want to do the punching operation or the blanking operation in the less amount of force, for that only you have to give the shear. अब shear का concept अपने घर में चले जाएं, वो जो चाकू होता है ना, चाकू पे भी आप एक धार देते हैं, shear देते हैं, that is a shear. So basically the shears are the inclined in nature. अब यहाँ पे समझे कि basically यहाँ जो shear आपने दिया है, that is a shear. So this is how, this is the distance, that is the S, amount of shear that you have given, and this is inclined by the angle theta. So what you can understand, S is the shear and theta is the shear angle. So from this configuration you can understand that theta is equal to tan inverse of S by D is the diameter, isn't it? D is the diameter. Now try to understand, if this is the earlier the punch is like that. Now try to, so this is the punch, try to understand, this is the punch, now this is the workpiece, this is the sheet. So if this is a punch, try to move the punch in the downward direction, try to move the punch in the downward direction. So earlier the configuration is this, now what you have done, your configuration is this is your configuration. Now after that, again if you will insert it down for the punching or a blanking operation, the punch will be here, the punch will be here. Now if the punch will be here, so you can understand this much P into T is the amount. देखिए P into T तो आप देंगे ही ताकि अंदर वो घुसे। अभी देखिए आपका S अमाउंट भी तो आएगा। देखिए टोटल अगर आपका ये जो है ना, ये जो आपका मटेरियल है, ये जो आपका पंच है, ये पंच अगर टोटल अंदर घुसे तो उसको टोटल कितना डिस्टेंस ट्रेवल करना पड़ेगा, ये P into T plus of S. So basically the punch travel in the shear case, when you are applying the shear, then the punch travel is basically P into T plus S. So this is the amount of punch travel that you are actually getting. So what you can write here, suppose in this, when you have applied the shear, so PS is the force required when shear is provided on the punch. So for that case, energy is given as PS into PT plus of H, where this is your punch travel. This is, in earlier case this was your punch travel, in this case this is your punch travel. Now you have found the energy. Now what I have told you that, see, the energy is being applied in the press by the flywheel or by the energy by the any other source. So basically the source is basically done in the almost all the cases, energy is supplied by the flywheel. So energy supplied by the flywheel is totally constant whether you are not providing the shear or whether you are providing the shear. So in both the case, the energy supplied by to the machine would be same. So for this case, if this is the energy supplied, that is the E, and this is the energy supplied, that is the E. So now if you would be equating both of them, that is the P max into PT, that is the PS into PT plus of S, then definitely you would be getting the PS as P max into PT by PT plus of S. Where what is the P max? P max is the maximum force and PS is the required force when shear is provided. And what is the S? S is the shear force. Now from this equation you can see here, so PT by PT plus of S. So PT would be smaller and PT plus S would be larger. So definitely from here, from this, if you would do the numbers calculation, you would be understanding that PS, that is the force required when the shear is applied, is always less. हो गया ना, काम तो अपना बन गया कि देखिए इस केस में मेरा ज्यादा फोर्स लग रहा था, इस केस में मेरा कम फोर्स लग रहा है, तो हो गई ना मेरी काम. And that is the reason why shear is applied on the punch. Now try to understand, if you have given the shear, then the graph is like that. अभी उस केस में PS है आपका फोर्स जो कि रिक्वायर्ड है, अभी आपने PT अमाउंट तो दिया ही और S अमाउंट एक्स्ट्रा आपका ट्रेवल हो रहा है, दैट इज द पंच ट्रेवल. सो फॉर द सेकंड केस व्हेन द shear is applied, for this case when the shear is applied, so for that case PT plus S, that is the amount of travel, that is the punch travel. So this is the punch travel and this is the PS. So this is the area under the graph, and hence this is the area under the graph. This is going to give me the E. Now try to understand, this is the energy for the first case when the shear is not applied. Now this is the energy for the second case when shear is not applied. So the difference is in the force, because the energy is actually same, है ना, एनर्जी सेम हो रहा है. तो ग्राफ से भी आपका चीज क्लियर हो रहा होगा और यहां से भी आपका चीज क्लियर हो रहा होगा. So I hope these things are clear to you. So what is the basic funda, why we are giving the shear? So we have seen that to reduce the shearing force, first thing, most important, it distributes the cutting action over a period of time. Okay, so period of time में ये distribute कर देता है cutting force को. अच्छा, एक चीज आपको मैं यहाँ पे बता देता हूँ. Sometimes what happens when you are giving the shear, when shear is provided, so when shear is provided, sometimes you will be getting the force versus the travel of punch. The force versus travel of punch graph would be something trapezoidal in nature also. ठीक है, अब एक चीज आप समझे कि आप जो है ना shear तो आप अपने हिसाब से देते हैं, you are giving the shear based upon your concern, based upon the requirement, है ना, रिक्वायरमेंट के हिसाब से तो आप शेयर देते हैं. सो फॉर दैट यू एक्चुअली मेक समथिंग लाइक दैट, अभी आप कुछ इस तरह का भी शेप का रिक्वायरमेंट के कारण आप बना सकते हैं, एनर्जी कुछ इस तरह का भी आए, कभी कभी आपका एनर्जी जो होता है वो ट्रेपेजॉइडल ग्राफ भी आ जाता है. सो बेस्ड अपॉन दैट डेफिनेटली डिजाइन, दिस इज द डिजाइन पॉइंट ऑफ व्यू, डोंट गेट सो मच इन डेप्थ डिटेल विद दैट, नथिंग इज इंपॉर्टेंट मोर देन दैट. जितना मैंने आपको बता दिया उतना मोस्ट इंपॉर्टेंट चीज है, उससे आपका सारा क्वेश्चन बन जाएगा. एक और चीज मैं आपको यहाँ पे बता दूं, सपोज दैट समटाइम्स व्हाट हैपेंस, दिस इज द पीएस, this is the PS that you have got, that is the PS is what, P max PT by PT plus of S. ये P क्या है, पेनिट्रेशन है, ठीक है, भूल नहीं जाना है आपको. अच्छा, ट्राई टू सी हियर, sometimes what happens that दिस P इंटू टी है ना, ये जो P इंटू टी है ना बहुत छोटा हो जाता है. समटाइम्स क्या होता है, ये बहुत ज्यादा छोटा हो जाता है आपके S के कंपैरिजन में. मतलब क्या, ये शेयर के कंपैरिजन में. तो देखिए, न्यूमरेटर से हम पीटी को निकालते नहीं है, लेकिन डिनोमिनेटर से पीटी के इफेक्ट को हटा देते हैं. क्यों हटाते हैं, अभी आप जरा सुनिए, प्लीज ट्राई टू अंडरस्टैंड हियर. PS वुड बी इज इक्वल टू P max इंटू PT बाई S. ये हम कर लेते हैं. अभी ऐसा हम करते क्यों है, वाई वी आर डूइंग दिस, वाई वी आर डूइंग दिस, बिकॉज आवर एम इज व्हाट. अभी देखिए, P आपको परसेंटेज में गिवन होगा, परसेंटेज में गिवन होगा. टी आपको सपोज करे ये आपका 40% गिवन है, अभी ये आपका टी गिवन है 3.5 mm. अभी आप अगर इसका कैलकुलेशन करने जाएंगे, इफ यू आर गोइंग टू डू द कैलकुलेशन ऑफ P इंटू टी, देन डेफिनेटली लॉट ऑफ टाइम वुड बी देयर. अभी अगर आपके पास समय नहीं है, देन ऑल्सो यू कैन नेग्लेक्ट दिस PT एंड डिवाइड बाय दिस S, and then also you can get the answer. But again, if this is the condition valid, then definitely you can neglect it and get the answer. So this is how you can guess your answers in examinations. Fine. So I hope you got the very clear idea. If each and every clear idea is everything is known to you, each and everything is clear to you, then try to solve this question. Now please try to solve this question. So I have got an answer from Khyati, that is 270 27.84. Okay, but Khyati, that is what you have found, Khyati, what you have found, determine the work done, right? Okay, if the percentage, very good, very good, very good, very good, Khyati, very good, very good. Basically you have found the work done. Please find the blanking force also, please find the blanking force also, please find the blanking force also. Please find the blanking force also. Okay, try to understand here. Estimate the blanking force to cut a blank of 25 mm wide and a 30 mm long from a 1.5 mm thick metal strip if the ultimate shear strength of the material is 450 Newton per millimeter square. ठीक है, तो पहले तो आप क्या करें, first thing that you need to do, you need to find the perimeter. So how you can find the perimeter? You know that there is a 25 mm wide and 30 mm long, right? तो आप जो है वो जो आपने जो निकाला है, जो ब्लैंकिंग करके निकाला है ना, product that you have found, so that is dimension is something like that. Okay, so this is 30 and this is 25, isn't it? So now what you can find, firstly you need to find 74.25. Khyati is telling 74.25. Very good, Khyati, very good, very good. So from here you can find the perimeter. So perimeter will be twice of 25 plus of 30, right? So this is the perimeter, this is going to be 110 mm. Now from here, okay, no problem. Very good, Nicole, very good, Nicole. Try to find the punch, that is the work done. Try to find the work done, Nicole. So here, that is twice 25 plus 30 is 110 mm. So this is your perimeter. Now from here you can find the shear area. Shear area. So shear area will be what? That is perimeter into thickness, है ना? Now this is 110 mm and thickness is given as 1.5 mm thick. 1.5 mm. Now you need to find the blanking force. Blanking force. So blanking force will be what? Blanking force will be, you need to find the uh, shear strength, right? The shear strength is given to you, that is the 450. Okay, so put it here, that is tau into shear area. Now tau is given as 450 Newton per millimeter square. Shear area is given as 110 mm, 1.5 mm. From here mm will get cancelled out, square get cancelled out. So from here blanking force, that is the P max, that you will be getting as 74.25 kilo Newton. Now see here in the next part they are asking about determine the work done. Determine the work done if the percentage is 25% of the metal thickness. ठीक है, अभी अगर 25% है मेटल का थिकनेस, पेनिट्रेशन जो है आपका, पेनिट्रेशन इज 25% ऑफ द मेटेरियल थिकनेस, देन हाउ यू कैन फाइंड द वर्क डन? सो बेसिकली ट्राई टू अंडरस्टैंड 27.84. very good, very good Nicole, very good Nicole, very good. So see here, you need to find the work done. So from here if you want to find the work done, so I have explained you the punch travel, concept of punch travel, isn't it? अभी concept of punch travel अगर आपका समझ में आता है तो punch travel is nothing. Punch travel is nothing. You have seen that 25% है आपका, परसेंटेज है 25%. तो पंच ट्रेवल आपका क्या मैं बताया, P into T बताया था. What is the 25%? 25% means what? It is 1/4. And what is the thickness which is given? Thickness is given as 1.5 mm, isn't it? So this is your punch travel. Fine. Now you need to find the work done. You need to find the work done, and work done is nothing but it is equal to energy, है ना? So this is what I have told you, that this is nothing but P max into punch travel, Now in the first case you have found the P max, that is 74.25. So 74.25 kilonewton. So just make it in the newtons for the calculation purposes. Newton into punch travel will be this 1/4 into 1.5. ठीक है, अब इसको सॉल्व कर लें, आपको एनर्जी आ जाएगा. ठीक है, तो एनर्जी विल बी, जस्ट लेट मी कैलकुलेट इट. ठीक है, तो आपको जो आंसर आएगा, now see here, that is this is in mm. Okay, so convert it in the meter. Fine, so you will be getting answer as 27.84. ठीक है ना, this is going to be your energy. Any doubt in this entire question solving? Any doubt in understanding anything? कहीं पे कोई डाउट है क्या? चलिए, so I assume that you don't have any doubt. So these things are for your practice. ठीक है, अभी ये questions, take this question for your practice. Okay, let me tell the answer of this question. This question would be, just solve this question. Very easy question is there. इसको solve ही कर ले आप, जल्दी इसको question को solve कर ले. In the blanking operation to produce a steel washer, the maximum punch load is given as 2 into 10 to the power of 5 Newton. Clear? The plate thickness is 4 mm, percentage penetration is 25. Mind it, it is percentage penetration. Clear? That is 25. तो इसको आप क्या कर लेंगे, इसको आप ले लेंगे 0.25. ठीक है, Nicole is selling option A. Very good Nicole. So basically they are asking about the work done. So what is the work done? Just now I have explained you, work done is nothing but P max into punch travel, है ना, याद रखना है, ये सब बेसिक चीजें हैं. And if everything is clear to you, you would be getting answers. So this is the maximum punch load. This is the maximum punch load that is given as 2 into 10 to the power of 5 newtons. Now punch travel is given. So what is the punch travel? This is the 25%. So whether you can take 1 by 4 or 0.25, this is going to be 0.25 into the thickness is 4. So basically the work done would be nothing but this is going to be 200 joule. That is option A. Option A. Very good, very good, very good. Now, now see here. This is the question. This is the question. Just before that, try to solve this question. I just wanted to solve this question because it's a very good question. Now try to solve this question. Can you solve this question? I'm giving you a 1 minute time and then I would be solving this problem. Can you solve this question? Can you solve this question? This is a manufacturing class, so this is for each and every branch. Okay, this is most focused about, this class is most focused about the mechanical and the PI students. Please try to solve this question. So I assume that you are not understanding this question. Try to understand here. I'm just explaining this question. In a shear cutting operation, a sheet of 5 mm thickness is cut along a length of 200 mm. Now try to understand that there is a sheet. Suppose there is a sheet like this. So suppose this is your sheet, and in this sheet there is a punch. Fine. अभी आप चीज देखें, ये shear cutting operation, a sheet of 5 mm thickness is cut along a length of 200 mm. So basically this length is 200 mm. Assume that this length is 200 mm. ठीक है. Now a cutting blade is 400 mm long. Now a cutting blade is 400 mm long. So see here, basically this is your cutting blade. Okay. This is your cutting blade. See here, this is your cutting blade like this, where this is the shear. Try to understand, this is the shear that is given. Okay, this is the shear, this is the shear theta. Here this is the S, that is the shear which is given, and this length is 400 mm. Now in this case, what is the problem? Try to understand कि यहाँ पर जो आपका ब्लेड है ना, ये जो आपका पंच है, ये जो आपका पंच है, ये पंच की लंबाई जो है वो 400 है, और आपका जो शीट है ना, शीट की लंबाई 200 है. मतलब कहीं ना कहीं अगर आप इस फिगर में देखें, तो 200 कुछ यहाँ पर आएगा, है ना. मतलब शीट की लंबाई ये हो गई, मतलब शीट की लंबाई 200 हो गई, है ना. ट्राई टू अंडरस्टैंड, शीट की लंबाई 200 हो गई, ये 200 जो मैंने यहाँ पे दिखा है, और इस पंच की लंबाई, इस कटिंग ब्लेड की लंबाई आपका 400 हो गया, है ना. तो कुछ इस तरह का फिगर आपको मिल रहा है. अभी what they are saying that the cutting blade is 400 mm long and zero shear, that is S is equal to 0. So here the zero shear is there, S is equal to 0. 2 here S is equal to S, है ना. that is what is happening, is provided on the edge, and the ultimate shear strength of the sheet is given as 100 MPa, and the penetration of to the thickness ratio is given as 0.2. अभी देखिए पेनिट्रेशन जो है ये आपका ऑलवेज रिमेंबर कि पेनिट्रेशन जो होता है ना वो आपका परसेंटेज में होता है, तो अभी आपको 0.2 दे दिया, मतलब आप समझ ले कि ये 20% आपको गिवन है, ठीक है। अभी अभी what you in this question they are telling that assuming force versus displacement curve to be rectangular, find the work done. Find the work done. Now see how you can find the work done. First of all, you have seen that work done would be is equal to, you have seen that work done is what, you can write L into T into tau. Clear? This is the force, that is the force that you are getting into P into T, that is the punch travel, है ना? ये आपने पढ़ा है कि नहीं पढ़ा? This is your punch travel and this is your P max. Now see here, this is the L. Now very important thing that you have to understand कि यहाँ पर कटिंग लेंथ की लंबाई 400 दी गई है, लेकिन चूंकि चूंकि इसकी लंबाई मतलब आपकी वर्कपीस मतलब शीट की लंबाई ही अगर 200 है तो कटिंग भी तो 200 तक ही होगी ना, ट्राई टू अंडरस्टैंड। if the length of the sheet is only 200, whether the length of the blade is more than that, I don't care about it, but how much amount of the cutting will be there, so cutting will be there up to this is the 200 है ना, ये कटिंग होगा 200 और ये आपका थिकनेस हो जाएगा, ठीक है। सो बेसिकली दिस इज गोइंग टू बी योर L into T, so basically from here you can write 200 mm कटिंग होगा आपका। थिकनेस क्या गिवन है इन दिस क्वेश्चन, थिकनेस इज गिवन एज 5 mm, clear, so put it here 5 mm. Shear strength is what, shear strength is given in this question, it is given as cutting blade is 400 and shear strength is given as 100, clear। shear strength जो given है वो 100 है, तो आप यहाँ पुट कर दें 100 न्यूटन पर मिलीमीटर स्क्वायर। now this into P into T, what is the penetration which is given in this question, it is given as 20%, that is the 0.2, so basically you can multiply it by 0.2 into T is the thickness, that is the 5 mm, so from here work done will be from here work done you can find it as 100 जूल, ठीक है। ये कन्वर्शन आप कर लेंगे यहाँ पर, ठीक है। ये देखिए आप यहाँ से mm स्क्वायर mm और mm कैंसिल हो जाएगा, यहाँ पे एक mm है, मल्टीप्लाई कर देंगे आप 10⁻³ से और आपको आंसर आ जाएगा वर्क डन 100 जूल, क्लियर। Now this is the question, in this question they are asking about the work done, so work done will be option A, that is the 100 joule. Now there is a linked question, in this linked question they are telling that if a shear of 20 mm, that is the S is equal to 20 mm, is now provided on the blade, भी बोल रहा है कि shear जो है वो 20 mm अगर प्रोवाइड कर रहे हैं हम, तो फिर आप मुझे बताएं मैक्सिमम फोर्स क्या होगी, क्या होगी, ठीक है। तो आप एक चीज बताएं मुझे, ये मैक्सिमम फोर्स की फॉर्मूला मैंने आपको बताया है, इफ यू कुड रिमेंबर दिस, see the maximum force from here you can find the maximum force, that is the PS. See this is the most important formula that I have explained you, this is the formula, okay। Now from here you can say that what is the P max, so can you say that from here if you want to find the force, so you can write this formula, right, you can write this formula, so put it here, So for this case, the maximum force, so maximum force could be written as, from here you can write that PS would be nothing but P max into P into T by P into T plus of S. इसको कैलकुलेट कर ले. अभी आप कैसे इसको कैलकुलेट करेंगे? सो PS would be nothing but what is the P max? What is the P max? What is the P max? So P max in the earlier case is this. This is the P max. This is the P max, isn't it? तो यहाँ से आप P max को निकाल लें. तो चलिए मैं यहाँ से पहले P max को निकाल लेता हूँ. P max would be nothing but this would be L into T into tau, where L is what, 200 mm, T is what, 1.5 mm. I hope T was 1.5 mm. Okay, so T was 5 mm and this is 100. Okay, so T was 5 mm and this is 100. ठीक है, तो यहाँ से आपका मैक्सिमम वैल्यू ऑफ जो फोर्स आ जाएगा वो हो जाएगा 100 किलो न्यूटन. 100 kilo Newton. Now see, you have seen that if you want to find the PS, that is the maximum force when the shear is applied, maximum force when the shear is applied, so you need to find the PS. PS will be P max into PT by PT plus of S. Now what is the P max? That is the 100 kilonewton, so you can write it here. Now what is the P into T? So P value is what? What is P into T? So basically, and see here, can you see one thing is there, one most important thing is there. You can see from here, this P max into PT. What is this? Can you write this as a work done? वर्क डन, इजंट इट? क्या आप वर्क डन लिख सकते हैं क्या इसको? तो देखिए ये भी आपका 100 किलो न्यूटन आ रहा है, वर्क डन भी आपका 100 जूल आ रहा है क्या? तो आप यहाँ पे डायरेक्टली ऐसा करें, यहाँ पे लिख दें 100 किलो न्यूटन इंटू दिस 0.2 into 5, 0.2 into 5 divided by PT, that is the 0.2 into 5 plus of shear. So in this question the shear is given as 20 mm. Shear would be 20 mm. Now from here just get a calculation and you would be getting F value as, just let me do some calculations. Now see here, one thing that you should always keep here, what is the shear that you have to put it here? What is the shear that you have to put it here? See, the shear of 20 mm is being told in this question. That means this is the shear. This much amount is the shear. Now your plate is having, see here, your plate is only of length 200 mm. Your plate is having only of 200 length mm. Now can you write like that, that if my plate is only 200 mm length, then this would be the effective shear. This would be the effective shear, isn't it? Now you can write here, this is your 200 mm, this is entire is your 400 mm, and this is your 20. So from here the effective shear, S effective, so from here you can find it here as 400. This is the 400, entire 400 divided by the shear 20. This is the length, that is the 200. This is equal to 200 by, this is the S effective, S effective. So from here you can find that shear, effective shear is 10 mm. Only the effective shear is 10 mm. Fine. So from here you can put here as 10 mm and from here you will be getting the answer. ठीक है, यहाँ से आपको आंसर मिल जाएगा, दैट विल बी अप्रोक्सीमेटली 9.09. अभी एक चीज आप समझे, 9.09 किलो न्यूटन. नाउ समझे, फॉर द क्विक कैलकुलेशन, डेफिनेटली फॉर द क्विक कैलकुलेशंस यू कैन ऑलवेज नेग्लेक्ट दिस पार्ट, है ना? आप इसको नेग्लेक्ट कर ले, पीटी को नेग्लेक्ट कर ले. क्यों पीटी को नेग्लेक्ट करिएगा? 0.2 into 5 जरा करके देखें, दैट इज कमिंग टू बी 1. नाउ I have told you this is the shear. So basically shear is what? Shear is 10 mm. So from here you can understand that shear is actually greater than पीटी, है ना। शेयर जो है वो काफी ज्यादा बड़ा है आपसे पीटी से, तो फॉर दैट रीजन यू कैन डेफिनेटली नेग्लेक्ट दिस एंड योर कैलकुलेशन वुड बी very much means like fast, and for that case you will be getting F as 10 kilonewton. Now you want to draw your attention in that in both the cases the answer is near, है ना, both the cases में आंसर नियर है, सो आप बेस्ड अपॉन द रिक्वायरमेंट यू कैन फॉलो विच एवर यू वांट, ठीक है। एंड फॉर दैट योर आंसर वुड बी ऑप्शन बी, है ना, ऑप्शन बी आपका आंसर आ जाएगा। एनी डाउट इन दिस एंटायर सेशन, जस्ट लेट मी नो। Any doubt in this entire session? So this is your question for the practice. Okay, this is your practice question. ठीक है, ये आपका practice question है. The answer, just let me write it here. Answer for this question is 2.9 degree. Take this as a practice question. Answer is 2.9 degree. And is there any other question? Okay, so for this is the question which has been asked in ESE 1994. So in this question they have been asking about the in sheet metal blanking shear is provided on punches and the dies, so that, so basically my intention, you have seen that my intention is to reduce the load, है ना, फोर्स की रिक्वायरमेंट हमें घटानी है, तो मैं तभी तो मैं shear देता हूँ. So for that reason my requirement is press load is reduced, right? So definitely for this reason we are giving the shear. Fine. So this is what is for the today's session. If you have any kind of doubt, just let me know. Otherwise, I'm going to end the session. If you have any kind of doubt in this entire session, just let me know. Just let me know. And if you're going for a plus subscription, use my code SIRVK SIRVK to get a 10% off, as well as to enroll in my personalized mentorship program. If you have enjoyed this video, definitely like this video and share this video in your friend circles. If you have any kind of doubt, please tell me. I'm here for you. If you have any kind of doubt, please tell me. I'm here for you. Otherwise, I'm going to end the session. I'm open for your doubts. Okay. So I assume that you don't have any doubt. So thank you so much for your active participations. I hope you are understanding. From tomorrow onwards, we are going to see the new topic, new things we are going to see here. And till then, thank you so much. I'm ending the session.